Dear students, now we are going to see the subject linear integrated circuit. The subject code is CC3451. Under that, the topic is analog multiplier and PLL. Analog multiplier and PLL is a non-linear circuit that produces analog signals are required for communication and control system. The integrated circuit components are used to perform the signal generation, rectification, modulation, demodulation, frequency translation, etc. Analog multiplier take the two analog input and produce a product as their output. The symbol of analog multiplier is given in figure. Here the inputs are represented by X and Y. So output is represented by V0, that is the product of a constant K into Vx into Vy. Here K is a scaling factor. Here V plus and V minus are the supply terminal where the dual input supply voltage of range plus or minus 15 volt is connected. The input V1 and V2 are connected to the input terminal X and Y. Performance parameters of multiplier: accuracy, the deviation of actual output from the ideal output of any combination of X and Y input falling within the operating range of multiplier. This deviation is called as total error. Linearity represents a maximum percentage deviation from the ideal straight line output where one input is varied from end to end and other input is assumed constant. An error surface is formed by plotting the output for different combination of X and Y input. The linearity error is defined as the maximum absolute deviation of the error surface. Bandwidth, the range of frequency where the output is 3 dB below its low frequency value. It is also called as a small signal bandwidth. Zero trim, the ability of the multiplier to set the feed through voltage at the output to 0. Scale factor, the proportionality constant relating the output voltage and the product of two input is called scale factor. That is the ratio of V0 by product of V1 and V2. Quadrant, define the ability of the circuit for bipolar signal at its input. The first quadrant device accepts only the positive input signal. The two quadrant device accepts one bipolar signal and one unipolar signal. The four quadrant device accepts two bipolar signals. Multiplier techniques. The different methods are available for performing analog multiplication: logarithmic summing technique, pulse height and width modulation technique, variable transconductance technique, multiplication using Gilbert cell, symbol multiplier using an emitter coupled transistor pair. Logarithmic summing technique. This technique uses the relationship given by ln of Vx plus ln Vy equal to ln of Vx into Vy. So, the multiplier circuit consists of two logarithmic amplifier. The input applied to the logarithmic amplifier is a function of the input, and at the output of the logarithmic amplifier is added together with the help of a summer. And in the output side we are having anti-logarithmic amplifier. This anti-logarithmic amplifier performs the inverse of logarithmic function. So output is the product of two input signal Vx and Vy. That means the Vz is equal to ln inverse of ln of Vx Vy. Inverse and ln get cancelled, so output is the product of Vx and Vy. So the relation between the output current and the emitter base voltage of the transistor is given by IC equal to I0 into e power VBE by Vt. The accuracy for this method is very low and the operation is one quadrant operation. This method has a strong temperature instability. Pulse height width modulation. The pulse width of a train of pulses made to be proportional to the input voltage and height of the train of pulses made to be proportional to the input voltage V2. Therefore, Vx equal to Kx into A, Vy is equal to Ky into T. That means height is related with A, width is related with time. So Vz is equal to Kz into capital T. Now capital T represents the area of the pulse, that is the product of height and width. This one is a rectangular pulse, so area of the rectangle is height into width. V set is equal to K set into T, that is equal to K set into A into T. V set is the given by the ratio product of Vx Vy divided by Kx Ky. The output is proportional to the pulse area and proportional to the product of two input signal. Emitter coupled pair. The emitter coupled pair produces an output current that are related to the differential input voltage. So output current IC1 is equal to IEE divided by 1 plus exponential of minus VI by VT. IC2 equal to emitter current divided by 1 plus exponential of VI by VT, where VT is the thermal voltage and base current has been neglected. Combine the above two equations to get the difference between the two output current. The output current del IC is equal to the difference between IC1 and IC2. Del IC equal to IC1 minus IC2, substitute IC1 and IC2. So del IC equal to emitter current into tan H of VI by 2 VT. So emitter coupled analog multiplier is shown in figure, and the transfer characteristics of this multiplier is shown in the second figure. The emitter coupled pair can also be used as a primitive multiplier. Assume the differential input voltage Vi must be less than Vt. The approximation is given by I emitter current into tan H Vi by 2 Vt equal to emitter current into Vi by 2 Vt. The change in collector current is equal to emitter current into VI by 2 VT. The current emitter current is actually the bias current for the emitter coupled pair. With the addition of more circuit, the emitter current is proportional to the second input VI2. So emitter current is equal to K0 into VI2 minus VBE on. Substitute this equation 12 in 11. So change in collector current is equal to K0 into Vi2 minus VBE on divided by 2 Vt. The circuit function as a multiplier is developed under the assumption that Va is small and Vi2 is greater than VBE on. The figure shows the simple modulator circuit that is constructed by using a differential amplifier. So the two-quadrant analog multiplier that is constructed with a differential amplifier. The advantages of this emitter coupled pair is low drift because of symmetrical IC construction, very high input resistance and high CMRR. Gilbert multiplier cell. The emitter coupled transistor pair has two limitations. The input voltage Vi2 is offset by VBE on, and Vi2 must always positive, which result in only a 1-2 quadrant multiplier operation. This two limitation can be overcome by Gilbert multiplier cell. All the transistors are identical and the output resistance of the transistor and biasing current of the source can be neglected, and the base current is also neglected. The collector current of Q3 and Q4 are given by IC3 equal to IC1 by 1 plus exponential of minus V1 by Vt, and IC4 is equal to IC1 by 1 plus exponential of V1 by Vt. So the Gilbert multiplier cell is shown in figure. This one is the two differential amplifier in balanced configuration is connected. So the collector current of Q5 and Q6 is given by IC5 is equal to IC2 divided by 1 plus exponential of minus V1 by Vt. IC6 is equal to IC2 divided by 1 plus exponential of V1 by Vt. The two current IC1 and IC2 can be related to the voltage V2. IC1 is equal to emitter current IE divided by 1 plus exponential of minus V2 by Vt. IC2 equal to emitter current divided by 1 plus exponential of Vt by Vt. So combining the equations 14 through 16, the expression of the collector current through transistor Q3, Q4, Q5 and Q6 have to be expressed in terms of input voltage V1 and V2. So IC3 equal to emitter current divided by 1 plus exponential of minus V1 by Vt into 1 plus exponential of minus V2 by Vt. Similarly, IC4 is equal to emitter current divided by 1 plus exponential of V1 by Vt into 1 plus exponential of minus V2 by Vt. IC5 is equal to emitter current divided by 1 plus exponential of V1 by Vt into 1 plus exponential of V2 by Vt. IC6 is equal to emitter current divided by 1 plus exponential of V1 by Vt, 1 plus exponential of V2 by Vt. The differential output current del I is given by del I is IC325 minus IC426. That is IC3 plus I5 minus IC6 plus IC4. So this can also be written by IC3 minus IC6 minus of IC4 minus IC5. So substitute this equation 17 to 20 in 21. So change in current del I is equal to emitter current into tan H of V1 by 2 Vt into tan H of V2 by 2 Vt. The DC transfer characteristics is the product of hyperbolic tangent of two input voltages. The signal applied to both the inputs are large compared to the volt equivalent of temperature, and all the transistors in the circuit act as a non-saturating switches. It detects the phase difference between the two amplitude limited signal. These two amplitude signals are required in PLL. This is known as a phase detector mode. Applications of Gilbert cell: a small signal precise 4-quadrant multiplier. The condition both the inputs are small with Vt. Loss signal phase detector with condition both the inputs are high with Vt. A pre-processing circuit in a flash ADC to reduce the number of comparators in this architecture. This is called folding ADC. The V input Vi2 must always positive, which result in only a 2-quadrant multiplier operation. So possible multiple choice question: determine the output voltage of analog multiplier providing the two input signal Vx and Vy. So output V0 is equal to Vx into Vy divided by V reference. Thank you.